Hello students. So now we are going to start with the problem number 3, which is based on composite function. So here we are going to take one composite function and we are going to find out the given result with the help of partial differentiation of composite function. So here we have u as function of x square plus 2yz comma y square plus 2zx, and we have to prove that the given result is equal to 0. Now guys, if you observe the given result properly, then here we want three terms or three partial differentiative term, which is del u by del x, del u by del y and del u by del z. Now guys, to get that we should have u as a function of x, y and z. Now if you observe here, then u is f of x square plus 2yz comma y square plus 2zx. It means it is not given in a proper format. Well, whenever we say that given function is in terms of x, y and z, we expect like u equal to something in terms of x, y, z, like x square plus y square plus z square. But here you can see that f also with these given two terms. So what we'll do is we will just rearrange the terms given in the question and we will rewrite the question and then we'll solve the given question. So what I'm doing here is I'm assuming this x square plus 2yz as r and y square plus 2zx as s. So this question will become u is equal to function of r and s, where the value of r is this and the value of s is y square plus 2zx. So guys, let's observe the given question once again. So here u is a function of r and s, where r is a function of x, y, z and s is a function of x, y, z. And here the relationship between u and x, u and y and u and z is asked. So guys, it is looking like a composite function because u is a function of some two variables and those two variables are the function of x, y and z. So this type of structure where we have a relationship between two variables with the help of an intermediate variable is called as composite function. So for this I will first draw the tree diagram, because with the help of tree diagram it becomes very easier to get the solution. So here I'll say u is a function of r and s, where r is a function of x, y, z, s is a function of x, y and z. So r and s are my intermediate variable, x, y, z are the independent variable and u is a dependent variable. So let's start. So to find out the value of del u by del x, here I will apply the chain rule from u to x. So from u to x there are two paths, one is u to r to x and u to s to x. So on these two paths I will apply the chain rule. So here we'll get del u by del r into del r by del x plus the second path is this, so del u by del s into del s by del x. Now guys, similar thing I'll do with del u by del y and del u by del z. So let's start. So now I have to find out the value of del u by del r and del u by del s, but guys these values are not possible because u is not defined. It is just given u is a function of r and s. So I'll not find out these two values. Let's find out del r by del x. So we'll differentiate this r with respect to x partial. Here we'll get 2x. So here I'll say it is 2x into del u by del r plus del s by del x. Let's differentiate this with respect to x partially. So here we'll get 2z. So 2z into del u by del s. So guys, this is the value of del u by del x. Now similarly we'll find out the value of del u by del y. So therefore the value of del u by del y is equal to, so first of all we'll apply the chain rule from u to y. So del u by del r by del y, then del u by del s by del y. So now let's find the value. Now value of del u by del r and del u by del s not possible because u is not defined. We'll find out del r by del y and del s by del y. So del r by del y will be 2z and del s by del y will be 2y. So here I'll write down. So here we got the value of del u by del y. Now let's find out del u by del z. So again, let's apply the rule. So del u by del r by del z, del u by del s by del z. So here we'll get again del u by del r, del u by del s not possible. Let's find out del r by del z and del s by del z. So del r by del z will be 2y and del s by del z will be 2x. So here we'll get. Now guys, we got all three values. That is the value of del u by del x, del u by del y and del u by del z. Now let's multiply it with some factor and let's add it. So let's see what we get. So here LHS is equal to, now we will multiply this del u by del x with y square minus zx, and that is why this 2x into y square is 2xy square. Next 2x into negative zx is negative 2zx square into del u by del r. Similarly, we will multiply this second term with y square minus zx. So we will get 2zy square minus 2z square x. So the first term is over. Next we have plus sign, so that is why here I have given the plus sign. Now we'll multiply the second term, that is del u by del y with x square minus yz. So just ignore this. It is x square minus yz. So here we have del u by del y. So if I multiply left hand side with x square minus yz, I have to multiply right hand side with x square minus yz. So here 2z into x square. So that will be 2zx square minus 2z into yz. So that will be 2yz square into del u by del r. Next plus second term into x square minus yz. So 2y into x square is 2x square y minus 2y into yz is 2y square z into del u by del s. So here second term is over. Now the last term, that is del u by del z, and we'll multiply it with z square minus xy. So here multiplying both sides with z square minus xy. So 2y into z square minus xy is into del u by del r as it is, and next I'll multiply this second term with z square minus xy. So this will become 2x into z square, that is 2x z square minus 2x square y del u by del s. So now guys, we got the LHS. Now let's take the similar terms together. So here you can observe that we have three terms of del u by del r. So I'll take these three terms together. So I'll take del u by del r common from these three terms. Similarly, from remaining three terms, I'll take del u by del s common. So let's see what we get. So here we'll say LHS is equal to, so if we take del u by del r common, in bracket we'll get this two terms, this two terms, and this two terms. So I'll write down those terms. So here we have 6 terms. Now from remaining 3 terms, I'll take del u by del s common and I'll write down this 6 terms in bracket. So we'll get now guys, let's add it. So first of all, let's check the bracket. So in bracket we have 6 terms and you'll find that the terms are opposite in sign. So we can cancel such terms. So here we have positive 2xy square and negative 2xy square cancelled. Negative 2zx square, positive 2zx square and negative 2yz square plus 2yz square cancelled. Similarly here positive 2zy square and here we have negative 2zy square cancelled, then negative 2z square x and positive 2z square x, and similarly these two terms. So it means guys nothing is left and that is why the answer is 0. So therefore we have proved the result, that is we have proved that this RHS is equal to 0. So I'm sure you understood the explanation. So guys, if you want to learn more about engineering mathematics, then keep watching Ekeeda, because this is the only source where you can get all engineering lectures under one roof. Thank you very much.